On the previous part, I have demonstrated how can we read the analog input values, which is the measurement in analog, using calculate function block. In this video, I'm going to demonstrate the commonly used function to read analog input values, which is analog measurement, using normalize and scale function. Using the same problem, this demonstration will show you the analog measurement for temperature sensor, which is measuring the temperature of an oven in terms of degree Fahrenheit. In this example, we are assumed to have a 12-bit analog input module, whereby the 12-bit analog input module will represent by a decimal number between 0 to 4095, and each decimal number of the analog input module is representing the temperature oven in terms of degree Fahrenheit between 50 degree Fahrenheit to 400 degree Fahrenheit. In this demonstration, I'm going to show you two function blocks, which is normalize x and scale x. Both function blocks can be found in the instruction library. Go to instruction library, basic instruction, then open the drop-down menu for conversion operation. We have both functions, which is norm_x and scale_x. Drag and drop the norm_x onto our network 1. Then we drag and drop our scale_x next to normalize x. So now we have both norm_x and scale_x. Take a look on normalize instruction, norm_x. So we have few terminals, which is n, which is enable. Then we have min, which is the minimum value. Then we have value, which is will be connected to our analog input. Then we have max, stand for maximum. Then we have eno, which is enable out. And we also have terminal out, which is output or result. Also take a note on those question marks. So we have question mark on the left hand side and the right hand side, which is we can select the appropriate data type for analog input and the appropriate data type for result. So for normalize instruction, basically it will map the minimum and the maximum value to a linear scale. For this example, our minimum value is 0, which is decimal number 0, and our maximum value is 4095, which is the maximum decimal number for 12-bit analog input module. So this minimum and maximum value, the decimal number, will be linearly scaled to a result which is between the value of 0 to 1. For scaling instruction, which is scale_x, we also have few terminal, which is enable, en. Then we have min, is for minimum. Then we have value. Then we have max, which is maximum. And we also have eno, which is enable out, and output, which is the result. So scale x will again map our value, which has been normalized between the value 0 to 4095 to 0 to 1, and scale x will scale the value of 0 to 1 to temperature value, which is between the minimum and maximum that we can set before. So according to our example, the minimum will be 50 degree Fahrenheit and the maximum will be 400 degree Fahrenheit. We have to check the appropriate data type for all the parameters that we use. So you have to pay attention on the data type set for the analog input. So on PLC tag table, so the temperature sensor, which is the analog input, the data type is unsigned integer. Download our programming onto PLC simulation. So we are in PLC simulation environment. So on the PLC sim, we can see that we have the temperature sensor for input word byte 64, and we have the output, which is a double word marker byte address 20. So when the temperature sensor is measuring value of 0 in terms of decimal number, the output will be 50 degree Fahrenheit. So take a look on our ladder diagram. Turn the monitor on. So when the temperature sensor measuring value of 0 decimal number, we're going to have the output of 50 degree Fahrenheit. On the normalize function, or the normalize instruction, this decimal number, which is in the value of between 0 to 4095, will be linearly mapped to value of 0 to 1. And this value of 0 to 1 will again linearly map to the temperature in degree Fahrenheit value of 50 to 400. Now we're going to try to manipulate the value of the temperature sensor using a force table. So we have to force a value between 0 to 4095 decimal number. Let's say we're going to try the maximum value of 4095. So now the temperature sensor is measuring a decimal number of 4095, which is the maximum, which is this maximum number. And this maximum value will be linearly mapped to a value of 1. And this value 1 will be remapped to a value between 50 to 400 degree Fahrenheit, and the result will be 400 degree Fahrenheit. Now we're going to try to manipulate or to modify the value of the temperature sensor for maybe two values between 0 to 4095. So again, using force table. So now assume we're going to modify 1500. In case of the temperature sensor measuring a value of 1500 decimal number, this value will be normalized to 0.3663004, and 0.3663004 will be remapped to a value in between 50 to 400, which is the result will be 178.2051 degree Fahrenheit. So we're going to try another value. So now the temperature sensor is measuring a value of decimal number 2080, and this value will be mapped to a value of 0.5079365. It is calculated automatically, and this value will be remapped to a value of between 50 to 400, and the output will be 227.7778 degree Fahrenheit.